So welcome back, students. In the first class, we have seen what is information and seeing an information how we can decide that what is the amount of information any message carries. We have taken three different examples. So among the three different examples, one message contains less amount of information, other one having moderate amount of information, and the third one contains high amount of information. And after that, we have seen if the message is having high probability of occurrence, that means that carries less amount of information. And if a message is having low probability of occurrence, that implies it carries high amount of information. From that, we also have established one relationship. The self-information is inversely proportional to the probability of occurrence of any event. And then we further represented the self-information of any event that can be your information as well as logarithmic of base 2 1 divided by pi. And we also have discussed why we are taking the logarithmic. And if we are taking the logarithmic, what the base of the logarithmic, whether it is 2 or whether it is 10 or it is e. So basically, we will take the base 2 of the logarithmic and we represent the unit of information as bits. So now in continuation of our previous discussion, let us take an information source which is S and which radiates different number of symbols, which I can represent by S1, S2, S3, so on so forth up to Sn. I've taken for example. And this many number of symbols which are transmitted by the source are having different probabilities. So I will take the probability of occurrence as P1, P2, P3, so on so forth, Pn. So what I mean to say that P1, that is the probability of information S1 or probability of symbol S1. So that implies the source S transmit the symbol S1 at a probability of P1. And the source S transmits the symbol S2 at a probability of P2. So on, we can say that source S transmits the symbol S1, Sn at a probability of Pn. Understood? Now, in this case, suppose I will take the transmitter is transmitting a long sequence of information. For example, if I will take my sequence is sequence length sequence length is L. Okay, where this L is very, very greater than N. So if you see here that the source which is transmitting n number of n different types of symbol, it is not about n number of symbols, n different types of symbol the source is transmitting. That does not mean the source is transmitting n number of symbols. The source can transmit 3 symbols. It can transmit 3 symbols. And those symbols are, for example, what I am telling, those symbols may be S2, maybe S3, maybe S5. It can be one possibility. The source is transmitting only these three symbols. Okay. So these are the different symbols that the source is transmitting. But I have a sequence length L which is very, very greater than N. So when length, that means the transmitter is transmitting a long length of sequences. So in that length L, there are so many symbols of S1 type are there. There are so many symbol types of S2 are there. There are so many symbol types of S3 are there, and so on like that. Are you getting the point? So if one symbol, a particular symbol S1 is transmitted at a probability of P1, and I have a length L, okay, that implies when the symbol S1 is transmitted at a probability P1, we can calculate the self information of S1. So the self information of what symbol S1, what I can write, that equals I1, that equals what is we have studied in the first class, log base 2 1 divided by P1, and the unit will be bits. Similarly, if we calculate the self information of S2, so that we can represent by I2, that equals log base 2 1 divided by P2, and the unit will be bits. Is it clear? But when, how many times the S1 is transmitted? S1 is a symbol, and the probability of occurrence of S1 is P1, but I have a total length is L. So as I said, there are so many S1s present in the whole length of L. There are so many S2s are there in the whole length of L. There are so many S3s are there in the whole length of L. But I don't know how many. I said so many. So how many S1s are there in the whole length of L? That equals probability P1 multiplied by length. So these many number of S1s are present in a whole length sequence of L. So how many S1s are there in the whole length L? That is the probability multiplied by length. So these many number of S1s are present in the whole length of sequence L. So if only one S1 is having self information I1, whereas we have this many number of S1s, so what is the self information of these many S1s? So P1 into L, number of S1s have self information equals to self information of one symbol is this one, self information of these many symbols is equal to P1 into L multiplied by self information of 1. So unit will be bits. Similarly, if we have to calculate what is the self-information of S2 in the whole length L, so that we can calculate P2 into L. These many number of S2s are present. Number of S2 have self information that equals to P2 into L log base 2 into 1 divided by P2, these many bits. Hope it is clear to all. In this way, if we have to calculate, let me represent it by dot dot dot. If for nth symbol Sn, so what is the probability? Pn into L, number of Sn have self-information equals Pn into L log base 2 1 divided by Pn. So these many number of bits. So what we observe that in the whole length of L, the self-information of S1 is this much. Whole, I am telling that whole length L. Okay, but this is the self-information of S1, only one symbol, S1. This is the self-information of only one symbol, S1, whereas this is the self-information of all S1s. How many S1s? P1 into L number of S1s. So all S1s are having self-information this much. All S2s are having self-information this one. So on like that, all Sns are having self-information this much. So what is the total information then? So total information is nothing but the summation of all self-informations because they are mutually independent. So what is the total information? Total information, or we can say total self-information. Total information is equal to the summation of all P1 into L log base 2 1 plus P1 plus P2 into L log base 2 1 plus P2 plus dot 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 Pn into L log base 2 1 by Pn. This is the total information. So which we can represent by I total. So can I write that I total is equal to taking L as common P1 log base 2 1 by P1 plus P2 then log base 2 1 by P2 plus dot 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 Pn log base 2 1 by Pn. So in this way, we have calculated the total information. The total information present in the bit sequence of length L. So what is the average information then? So average information, which we can write I average. So average information is nothing but the total information divided by the sequence length. So if we divide it by L, so L will be cancelled. So this equation will be P1 into log base 2 1 by P1 plus P2 log base 2 1 by P2 plus dot 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 Pn into log base 2 1 by Pn. So I can write the average information I average is equal to summation I equals to 1 to n Pi into log base 2 1 by Pi. So this is a very important equation that gives the total expression of total not total, average information. So this is also called as entropy. And the unit of entropy is bits per symbol. Why bits per symbol? Because we have L number of symbols. Okay, so total information is the unit of total information is bits. So we divided by how many number of symbols? We have L number of symbols. So it is bits per symbol. So average information is the unit is bits per symbol, and this is the equation of average information, and that is otherwise called as entropy. Okay, so entropy means it is the average information present in a bit sequence. So any question from your side? Okay, no question. Now, so once we have the idea of average information, we can go for another parameter which is related to the entropy or related to average information as well. That is called information rate. This is called information rate, and it is denoted by RS. So how we can define information rate? So information rate, it can be defined as that what is the amount of information present in a symbol multiplied by the symbol rate. Okay, so I will write it here. This information rate RS, it can be written as the average information per symbol multiplied by symbol rate. Understood? Multiplied by symbol rate. That implies what is average information per symbol? So average information per symbol we have evaluated, that is nothing but our entropy. That is nothing but our entropy multiplied by symbol rate. So symbol rate we have denoted by, let us denote by small rs, because we have represented capital RS as the information rate. So let me denote small rs as the symbol rate. And what is the unit of this symbol rate? The unit of symbol rate is symbols per second. Symbols per second. So this is the unit of symbol rate. Okay, so what is the unit of your average information? We have written over here. So its unit is bits per symbol. Okay, it is nothing but bits per symbol. So if you multiply this unit beats per symbol with symbols per second, so symbol will cancel out from the numerator and denominator, and finally it will have a unit that is beats per second. So beats per second is the unit of your what? Information rate. Okay, so if you understood this concept, now let us take an example based on the entropy and the information rate. So I will write the question over here so that you can read the question mindfully and try to answer the question. The question is, a discrete source emits one of 6 symbols once every millisecond. The symbol probabilities are, this is D, are 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, and 1 by 32, respectively. Then the question is, find the source entropy and information rate. So this is the question which is asked to you. So try to read the question mindfully and understand what has been given, what has been asked, and how we can proceed to find the answer. The question is, is discrete source emit one of 6 symbols? Okay, so what is the length? There are 6 symbols, so length is 6. So there are 6 symbols once every millisecond. Okay, so that means what? The source emits one of 6 symbol every millisecond. So once one symbol is emitted, after 1 millisecond, another symbol will be emitted. After 1 millisecond, another symbol will be emitted. Then after 1 millisecond, another symbol emitted. So on like that. So every millisecond, one symbols are emitted by the source. Okay, so what is the time difference between 2 consecutive symbols? That is 1 millisecond. Okay, so time difference between 2 consecutive symbols is 1 millisecond. That means the symbol duration is 1 millisecond. Then what is the symbol rate? We represent symbol rate by small rs. So that is equal to 1 divided by 1 millisecond. That is equal to 10 to the power 3. So 10 to the power 3 symbols per second are transmitted by the discrete source. So this is what given in the question. Now moving to the next part of the question, the symbol probabilities are 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32 and 1 by 32 because there are 6 symbols. So 6 probabilities are given. So that means symbol 1 is transmitted at a probability equal to 1 by 2. Symbol 2 is transmitted at a probability that is 1 by 4. Symbol 3 is transmitted at a probability that is 1 by 8. Symbol 4 is transmitted at a probability that is 1 by 16. So on symbol 5 is transmitted at a probability 1 by 32 and symbol 6 is transmitted at a probability that is 1 by 32. Understood? Now, if you add all those probabilities, that means 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32 plus 1 by 32, the sum of all probabilities will become 1. So looking at the probabilities, if I will ask which particular symbol is transmitted with or which particular symbol occurrence is more, which is the symbol which is frequently being transmitted by the transmitter or frequently being emitted by the transmitter. Yeah, you can answer in the chat box and you can answer in the question and answer section also. So the answer to that is the symbol S1 is transmitted with high frequency and symbol S5 and S6 are transmitted with low frequency. That means the occurrence of symbol S1 is very high in comparison to S5 and S6. No, in comparison to all other symbols, the occurrence of S1 is very high. Okay, because it has a high probability. And if any symbol is occurrence is high, so the information content in that symbol is less. That means self information of S1 will be less. If you calculate, it will come less. Okay, so anyway, let us answer to the question. So the probabilities are given. So what has been asked here is that to find the source entropy, we have to find source entropy, and then after we have to find the information rate. So what is the expression of source entropy? It is one more thing which I forgot. This source entropy, it can be represented by H of S. The symbol symbolical representation of source entropy or average information is H of S. So this can be written as H of S is equal to the summation I is equal to 1 to 6 because here my n is equal to 6 because 6 different symbols. It is given here, emit only 6 different symbols. So I to 6, pi, then log base 2 1 divided by pi. This which I can expand as p1 log base 2 1 by p1 plus p2 log base 2 1 by p2 plus p3 log base 2 1 by p3, then plus p4 log base 2 1 by p4 plus p5 log base 2 1 by p5, and finally p6 log base 2 1 by p6. So we can write h of s is equal to, what is the value of p1? P1 is equal to 1 by 2, then log base 2. Here it will be p1, so 1 by 1 by 2 is equal to 2, then plus 1 by 4 log base 2 4. Directly I am writing plus 1 by 8 log base 2 8, then plus 1 by 16 log base 2 16, and plus 1 by 32 log base 2 32 plus 1 by 32 log base 2 32. So if you calculate this value which I have calculated, it is coming 1.9375. 9375. What is the unit of this? Unit is bits per symbol. So this is the amount of, or average amount of information present per symbol. So this is called the entropy, or average information, which we have calculated. And this has been asked in the question to find source entropy. Next, it is asked to find the information rate. So information rate can be calculated as Rs, that equals to h of s multiplied by Rs, where Rs stands for symbol rate. So we have calculated the h of s, that is the entropy or average information, that is 1.9375. This is bits per symbol multiplied by our symbol rate. Our symbol rate we have calculated from the very beginning of the example, that is 10 to the power 3. So this is 10 to the power 3 symbols per second. So this is 10 to the power 3 symbols per second. Okay, so this equals, symbol will cancel. So 10 to the power 3, if you multiply with this, it will be 1937.5, this much bits per second. So this is the information rate. Okay, this has been asked in the question to find information rate. I think you have all followed the question and followed the approach how we have solved the example. Now, let us take one more example. So this is example number 2. We have time. The question is, a code is composed of, this is E. A code is composed of dots and dashes. Assume that a dash is 3 times as long as a dot. Okay, a dash is 3 times as long as a dot and has 1/3 the probability and has 1/3 the probability of occurrence. Calculate bit A, information in a dot and dash. Second point, calculate the entropy of dot dash code. Entropy of dot dash code. Third, the average rate of information. Average rate of information if a dot rate of information if a dot lasts for 10 milliseconds, last for 10 millisecond and this time is allowed between symbols, is allowed between symbols. So this is the question. Let me show the question to you. Please read the question and try to understand. So what is given? A code is composed of dots and dash. Okay, so a code is there. So this code is having dot dash dot dash dot 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 dash in a random manner. I don't know. Okay, in what manner it is there, I don't know, but it is composed of dots and dashes. Correct. Now assume that a dash is 3 times as long as a dot, okay, and has 1/3 of the probability of occurrence. So what is given? Solution. It is given that a dash is 3 times as long as a dot. That means the length of the dash is 3 times than that of a dot, and the dash has the probability of occurrence, that is 1/3. Okay, so that means what it is given. If we consider a code which is composed of dot and dash, you read this particular line carefully. The length of a dash is 3 times larger than a dot. Okay, if a dot is having length, suppose 1 micro meter or something, micrometer, then the dash will have a length of 3 micrometer. So if we constitute one dot and dash, they will have 4 micrometer. 3 micrometer plus 1 micrometer, it will be 4 micrometer. Okay. So that means consisting of one dot and one dash, the length is 4 micrometer. So what is the probability of occurrence? The probability of occurrence of dash is 1/3. Okay, so we can write here the probability of dash. The probability of dash is equal to 1/3. Similarly, we can write the probability of dot is equal to 2/3. Why? Because we know the summation of two probabilities, that is probability of dot plus probability of dash, they must become 1. Okay, so if it is given the probability of dash is 1/3, hence the probability of dot will be 2/3. Now, if we come to the first question, it has been asked to find the information in dot and dash. So what is information? So first is information of dot, that is I dot. So I dot is equal to P dot into log base 2 1 divided by P dot. So that equals P dot is equal to 2/3 and log base 2 1 divided by 2/3. So that equals 2/3 log base 2 3/. Similarly, probability, that self information of dash, that is P dash log base 2 1/P dash, that equals, so P dash is 1/3 into log base 2. All right, now next question, you have to calculate the entropy of dot and dash code. So what is the entropy? So second question is the entropy. So entropy is represented by Hs. So that equals to the summation of I is equal to 1 to, here it will be two different symbol we have. one symbol is dot, another symbol is dash. So pi log base 2 1 by pi. So that is equal to p dot log base 2 1 by p dot plus p dash log base 2 1 by p dash. So we have calculated these two probabilities in the first question. So this is nothing but this one is nothing but, you see, what is the information in dot? So no, let me correct my mistake. Listen carefully. It is the information is not multiplied with p dot. Don't multiply with p dot. Not multiply with p dash. Correct. So this is the information. Even let us see our previous example what we have done. This is correct. Yeah. If you have to calculate only information, then information is log base to 1 by probability. Correct. So this one, this is p dot, and this one is I dot plus p dash into I dash. Okay. So after calculating all the values, you can put those values in the respective points, and you can find out the final answer. So we have completed the time, and tomorrow when we'll meet, we'll try to solve the third bit of this question. And if you have any question, then you can ask me, or else we can end the session today.